I have already reviewed Bob's corn ethanol facility's energy consumption. Now I will recommend some ways that Bob can use emerging technologies to reduce the environmental impact and energy consumption. There are many ways to do this, but for now I will introduce one possible solution so that Bob can discuss it with his planning board and get back to me with feedback. I see from examining the production flowchart that you use a traditional dry milling process to produce ethanol, and you have co-products of distillers dried grain with solubles, DDGS, and wet distillers grains with solubles, WDGS, which are both sold as animal feed. Your facility's energy consumption consists of thermal energy for cooking, distilling, and drying, and electricity to operate motors, fans, and pumps, totaling about 30,000 BTU per gallon of ethanol produced. Here's how I recommend you modernize your corn ethanol facility. We can add a fractionation process unit to separate the corn kernel into its main components such as the pericarp, the endosperm, the germ, and the tip cap. This will give you additional co-products that can offset the cost of production. The corn oil co-product harvested from the germ can be sold outright. The pericarp and tip cap together will provide you with cellulose and fiber biomass co-products. You can decide what to do with the cellulose and fiber biomass, which makes this process adaptable. You could just sell the bran as a feed product, but if you want to be really innovative and environmentally friendly, you can use the bran as a biomass energy feedstock. This means you would combust the bran in a solid fuel boiler system to provide for your facility's thermal energy needs, which would offset 3,500 BTU.
Wow, that sounds great. I'll get my process engineers right on that fractionation unit.
You haven't heard the best part yet. If we also include anaerobic digesters and advanced motors, we can lower the energy consumption of your facility from 30,000 BTU per gallon to 22,010 BTU per gallon. In addition, 21,000 BTU per gallon will be offset by the biogas produced in the anaerobic digester. So if you combine these systems, the fractionation, solid fuel boiler system for the bran, anaerobic digesters, and advanced motors, you can give your plant a net surplus of 2,490 BTU per gallon.
What do we do with the surplus in energy?
Combined heat and power systems, also called cogeneration systems, can generate electricity from your surplus of thermal and electrical energy. That energy can be sold back to the grid as a co-product, saving your company even more money, and reducing the impact of the electrical power grid on the environment. I will email you the contact information of some trusted bioengineers from the Chemical and Biological Engineering program at Colorado State University to help you with the anaerobic digester process system. Those guys are pros.
That sounds great. Let's do that. Goodbye. Ethanol production nowadays has become a component that can be used in different fields, thus making this product very scarce. And production facilities are researching new methods to produce ethanol. Ethanol is mostly used as fuel. The increment in renewable fuel sources has pointed out a new direction for ethanol production. One of the goals in the U.S. is that by 2030, at least 30% of the fuels come from renewable sources. In one of the research facilities, engineers are working on new ways to produce ethanol. Let me present Robert, who will explain.
Hi there. My name is Robert, and I make part of a team of biological and chemical engineers that specialize in finding new methods to improve ethanol production. In this facility we think that ethanol production can be achieved by using waste products from different food processes. For example, a byproduct raw material manufactured in the sugar and juice industry such as pectin biomass could be used to produce ethanol. This is because pectin biomass consists of a complex carbohydrate that can be found in residues from apple pomace and citrus waste. The main difference between corn kernel and pectin is that pectin biomass contains a low lignin concentration, and this is important because lignin interferes with the enzyme degradation that facilitates ethanol production. Pectin biomass cell walls contain 12 to 35% DW-pectin compared to corn kernels or grass that only contain 2 to 10% DW-pectin, which describes the higher percentage of water-soluble carbs that are present and less lignin within the structure of pectin biomass. The process of how pectin biomass is transformed to ethanol consists in forming sugars from the pectin structure by degrading and enzyme digestion. The next step consists in fermentation, and this can be accomplished two ways. We can compare the use of Saccharomyces cerevisiae and E. coli. Saccharomyces cerevisiae has a high substrate concentration toleration, a high ethanol concentration, and a low pH and O levels, while E. coli has a higher optimal pH, does not tolerate ethanol effectively, but ferments wide range of sugars,